Live. Hello, everyone. Welcome, and thank you so much for being here. I am so excited to share with you all the wonderful projects that the bounty hackers created during the 6-week trial of a bounty hack. I am not just saying this, I truly mean it. I've had the great opportunity of getting to know some of the teams working on these incredible projects, and it's been very rewarding to get to know every single one of you and also just see where your passions lie and how ambitious you are in achieving such great results, whether it be locally or at a global scale, through your ability to build now blockchain applications. I'm truly seeing you all see how viable it is to adopt blockchain and build on blockchain. So it's really exciting. And I want to thank you all for being here. I'm really excited to welcome Candace, who's our head of community here at Reach. She's going to be sharing a little bit more with you guys about maybe what happens after this bounty hack and the possible opportunities for you all. So I'll welcome her on stage.
Thank you, Estef. Thank you so much. Hi, everyone. It's good to be here. You know, I have now been part of Reach for about 6 weeks or so, and this was the first bounty that I got to be part of. And I cannot begin to tell you how very inspiring it was to see the excitement that I saw in Discord, to watch people work together, to see what they created. There was just so much activity that went on during this bounty hack. And it said to me, I want to do another one in Africa. These people are brilliant and they have bright futures. So that's where I'm leading into what's going to happen after the hack is over. So I want the opportunity to find out what each and every one of you wants. If you're interested in becoming a future mentor for another bounty hack, if you're interested in finding work, we are working with a lot of companies that are excited about Reach as well. And then we're working to kind of bring everybody together to make a bigger and stronger community, because we are really nothing without our developers. So don't be shy. Tell me everything that you want and dream for, and I'm going to work towards getting you what you want. Okay. That's what I have for now. Again, don't forget to reach out to me. I'm Candace at reach.sh, and whatever you need, I'm available for.
Wonderful. Thank you, Candace. Appreciate it. Now, next up, I'm going to welcome Ben with the Africa Blockchain Alliance. Hey, Ben.
Hi, everyone. Welcome to today's event on the Bounty Hack 2. I don't really have much to say, just to thank everyone that participated. I want to thank especially the folks at Algorand for putting this together. Algorand is a great platform, and they're really interested in kind of moving blockchain forward, and it's a great opportunity for everyone to learn about a new blockchain, and just for the great work that they're doing. I want to appreciate them, and also for Reach with the great platforms that they have that makes it easy for people to get onboarded onto the blockchain. So it's been a hectic few weeks for many of you. And again, also back to you, the participants, thank you for participating. And it's really not the end. There's a lot of opportunities, like Candice mentioned, for you going forward. It's just for you to let us know, and then we can try to point you to the relevant opportunity that works for you. So lots of things that are going to go on. We will definitely have another one. The reception has been great from the community and from everybody, and we definitely look forward to that. So, I would like you to keep participating, especially for the next one. And for those of you that have already participated, it would be great to be a mentor. for the next one. So keep up the good work, and we will be in touch with details of when the next one is going to kick off. But kudos, take everything that you've learned and put it into practice. And yeah, just this is just the start of something great for you. So well done and all the best. Thank you.
Thank you, Ben. That was great. All right, there you have it. Yeah, major shout out to Algorand, the Algorand Foundation, for supporting these bounty hacks. If it wasn't for them, we wouldn't be able to fund these projects and also be able to get you across the finish line with such support from the mentors and other participants, hand holding along the way and offering you their support. I see JP is here as well. I'm going to bring him on stage and see if he wants to say a few words. Hey.
Hey everyone. I really don't belong up stage. I hardly do anything with these except be a mentor. But I'll just say that it's great to work with everyone, especially my mentees and the people that I had a chance to interact with in the office hours and the Discord. It's really great to see all of your progress, and I can't wait to see the showcase. I want to make a plug for being a mentor in the next Umoja bounty hack, or one of the next bounty hacks that Reach participates with Algorand. One of the best ways to learn something is to teach it. When you teach something, you learn it twice. You have learned something already, and then you get the opportunity to hear problems from another person's perspective, and then it forces you to understand the code that they've created or the problem that they're trying to solve. And it really helps you think through solving a problem, especially one that you're not so deeply ingrained in, right? And so be a mentor. It's a really great opportunity. There's a huge need for mentors, and we would love for you to continue in the community. And it's also a great way to make a name for yourself. Everyone loves their mentors. I had a great pleasure being in the office hours with all of you. Thank you so much to everyone who came to them. Thank you for all of you who watched the recordings. Thank you all for all of your questions. We really love your questions, and we hope that you'll continue to participate in the Discord, asking your own questions and even helping others answer their questions. We want to see you there and keep developing. And to second what Steph and Candace and Ben have said, let us know what your goals are and what you want to do, and we want to help you. Thank you.
Thank you, JP. Appreciate it. I do see that there's also a few participants who are currently backstage. I am going to try and bring them on stage. Some of them might say something, maybe not, and that's okay. Hello, hello. I have Murdy and Daniel here. Thank you guys for joining us. It's a pleasure to have you here. And I wanted to give you guys the stage for a few moments. I'll start with Daniel and then Murdy. If you could just share with me a bit about your how the hack was for you, if this was your first time building a blockchain application, and what that experience was using Reach.
Yeah, hello everyone. Yeah, my name is Daniel Chooks. I want to say this is my first bounty hack. It was fun at the time. It was challenging, but I mean, life comes with a lot of things. So it was fun. It was interesting. I had to learn a new language in a short period of time, which was motivating. I had a lot of people to ask questions. I remember being stuck at the time, and I had to go to the help channel, and so quickly I got a response, and the help was so fast, and I could fix my problem in less than 2 minutes. So the community is actually loving. It's actually interesting. So it wasn't like I was alone in a period of time. I actually learned a lot this period. I also learned about unity and commitment. Actually being able to interact with other hackers. It was actually fun for me, and my project actually was inspired by a lot of things around. I built a unique number project, and believe me, I love what I built, and I'm really excited about. I'm happy to be among a family like this to build something unique with Rich. Thank you.
Yeah, I guess I'm the next. All right. So First of all, I want to thank the Rich platform and Algorand for putting together something like this, especially for like something that is focused for Africa developers. And this was really an awesome time learning, like coming from maybe the Web 2 world, learning like having something like Reach to fall back on while building applications that are secure by default. It was really, really like an amazing time. And also, as Daniel has just said, there was really help from the Discord. So whenever you get stuck, you could just jump in the Discord and get help at any time. Because imagine people are in different time zones, but there was time I could wake up at 2 a.m., post my question, and get an answer like right away. And that was really an awesome thing. And and maybe something I would like to tell the other developers who built something and the people who want to build is that like we shouldn't be afraid of coming into such hackathons and build projects. It's really a good learning opportunity since you are out of your comfort zone and you really see like the development aspect from another side, and it's just fun, even if some people don't cross like the line on time. It's just fun, the learning process and coming to connect with other people, interact with new technology, and getting help from the Discord. I'm going to emphasize on that again because I think that part was really helpful for most of us. So for the people who built, maybe I would encourage all of us to come back maybe as mentors and help the next cohort and the next builders get the same help that we got. So yeah, that's all I have to say. Thank you.
Wonderful. Thank you both so much for taking the time to share that with us. I really appreciate it. I'm going to take you guys off the main stage now. Please enjoy. All right, and there you have it. You heard it firsthand just how incredible it is to participate and challenge yourself to reach new heights, new opportunities, because you don't know what you're capable of unless you try. So again, thank you for being here. I'm going to share with you all a little bit more about the next steps after demo day, like content incentives, what opportunities are available in that realm. Give me just one moment while I share my screen. Here we are. Okay. So this is Decentralized Umoja 2. We are going to have a third one coming up in the next few months, so stay tuned. Currently, there are 2 bounty hacks ongoing. It's a little late to participate in those, but I would suggest staying tuned for the next one and mentoring the ones coming up. There's plenty to do, and we need all the help we can get. Okay, so as you know, we've postponed voting for this weekend. So voting is going to begin tomorrow at 3 p.m. South African Standard Time, and it's going to end Monday at 3 p.m. South African Standard Time. And this is so that you have 48 hours to review, whether it be the GitHub repositories or observe demo videos from all the other participants who also took part in the hack. And we're going to be placing first, second, and third prize. We're going to be announcing this on Friday next week when we'll have a secondary awards ceremony. Now, some things to be mindful of is the rules regarding voting. So every team is allowed to vote for 2 projects, okay? For 2 projects. The only rule is you cannot vote for your own project. I will be checking. And today we're here to celebrate you, to showcase the amazing work that you've done. To those of you who were able to complete and submit your demo videos on time, we will be showcasing 16 of those projects today. Some of you are running a little behind, and that's totally okay. You are still eligible to receive payout of the remaining $800. And you are still eligible to also complete the incentives. So you are not missing out on completion of the bounty. You're not missing out on the incentives. So I'll get into the incentives a little bit further. So we still want to encourage you to get across the finish line. So if it's assistance that you need, like help answering technical questions, maybe there's some bugs in your code and you're not sure what's going on, you keep seeing some errors that just don't make sense, please do reach out. Join us on the Discord. As you know, we're readily available to answer your questions, or ask your mentor. Your mentor should be there to also facilitate your progress along the way. Okay, and then the Community Choice Award. This one's a fun one. So we do open up voting to members outside of the hack. So this is where we invite you to tell your mom, your dad, your sisters, your brothers, your friends, anyone who wants to support you to come and vote for you for the Community Choice Award. So what we'll do is we're going to be hosting voting. And it's going to start on Wednesday, May 4th, and it's going to end Friday, May 6th. So that's going to be another 48-hour window for your friends, family, and colleagues to come and vote for you to possibly win the $1,000 of the Community Choice Award. Now, you still have the opportunity also to complete content incentives. You can win up to $1,700 in just content incentives, and I'll go over those numbers right now. Okay, so project completion is going to be the $800. Some of you have already been paid out for a lot of the progress. Some of you, I still have to send over some funds, and I will do that soon. You're also given $250 if you complete an article just describing your project and your experience during the hack. Talk to us. We want to know whether you had trouble with the platform, and if it's written, sometimes it's the most helpful way for us to improve what we're doing. Then many of you have also already scheduled this call and have done this with me already, is do the video interview via a call where I ask you some questions about your experience, where you want to go, and what you want to do with your blockchain skills. You also have the opportunity to either, one, create a workshop or a tutorial. Both workshop and tutorial outlines are available within our documentation. If you need any extra support, I've been connecting individuals to JP. I hope he still has time in his calendar to support the rest of you who have yet to do this. But please, if you need extra support and help on how to go about this, we're on Discord, so we want to support you to get through this. The deadline for these content incentives is going to be at the end of May. So you have this entire month to complete these. I would say the sooner the better, because this also allows for you to campaign and allow your community to vote for you along the way, especially for the Community Choice Award. So thank you all for joining us, for being here, and for just believing in yourselves to take on this new adventure or venture. So now I'm going to be playing the videos. So pardon me while I get this ready. If you have any questions too, this is probably a good time to ask here in the chat. I can take a look at these in the next minute. Here we are. Okay, without further ado, here we are. Enjoy. Okay, bear with me. I hear there's an audio issue, so I'm just going to make sure that we can actually hear everything. Okay. How about now?
The contract. Right, so we can see what's going on in the console. So once we get the orders, we'll be able to interact and send our front end to the back. So once something is printed here, we'll be able to send it. Accepted wager. Wager has been accepted. All right, I can play my hand now. So I've made my shot, and this shot will be sent to the back end to compare if it actually hits. So the back end is like a proof. All right, I sent it. It didn't hit. So the AI will make his own shot. So the enemy has fired, and where did he fire? He made the shot here. So that's just basically one challenge I faced when implementing this game was the application time, like the time to interact with the blockchain and everything takes too long. So I was hoping that I could implement a better version of this game that won't involve the long waited times.
Hi everyone, my name is Paul Ogulumba and I built the Dara project. Yeah, so Dara is the name of a game, a board game actually, that I used to play growing up. It is quite common in the northeastern part of Nigeria. So the rules are simple. Each player starts off having about 5 or 6 pieces. The board is mostly a 6 by 6 square or an 8 by 8 square, depending on specifications that the players choose. So how the game goes is each player takes a turn to place one of their pieces on the board. But while placing your pieces on the board, there are some rules you cannot break. The first rule is you cannot place a piece in a position that would make you have 3 pieces or more aligned horizontally or vertically on the board, like next to each other. You can't do that yet till after you've put all your pieces on the board. And after all your pieces are on the board, you can now start moving them around. You can move them in either the vertical direction or the horizontal direction, but you can't move them diagonally. So the aim of the game is to move your pieces around and get a vertical or horizontal match of 3 pieces. So once you achieve a match, that means your opponent will skip the next turn, and then you would have the right to take away a piece of theirs from the board. So you win if you can take away as many pieces as possible till your opponent has 2 pieces left. So once you do that, you've won the game. So it's actually fun to play, and it's kind of similar to tic-tac-toe. Yeah, so this is the index.rsh file of the contract that the game is based on. Yeah, so on line 6, so I put some checks to make no player cheats, and one of the checks is that each player publishes the number of pieces they have on the board and the number of pieces that they assume the opponent has on the board to the contract. And the contract checks to make sure that each player calculates the same number of pieces for both them and the opponent. One of the checks I put, you can see where I wrote a function that does that for me. Okay, so this function here, const winner, it just calculates the outcome of the game by checking the number of pieces each player has. If any player has fewer pieces than 3, and that player has lost. Yes, over here you can see the interact interface for my participant class. Actually, 2 participants play the game, just obviously. So Alice sets the wager and the deadline. Each player has to play within that deadline. If not, the game cancels, and the other player gets paid the wager. Yeah, so Bob gets to accept the wager. You can see the interact functions that they have in common. There's get number of pieces left. This function gets the number of pieces that each of the players has and the opponent has. So as you can see, a deal piece function, this is when a player makes a move. So after you make a move, you publish it to the contract, and the contract sends the move to your opponents via this update opponent move. All right. So this is where we inform timeout, inform disagreements, and then announce winner. Yeah. So the flow of the game is quite simple. It's straightforward. Yeah, and here I incorporated a while loop. So this loop runs throughout the game. It only terminates. It only terminates when the current outcome, is not continuing. So over here you can see where I listed all the outcomes. So the outcome can either be B wins, a draw, A wins, continue, or terminate. So terminate happens when the number of pieces that each of the players publish don't match. Yeah, so I would do a quick display of what the game is like, and I hope you enjoy it. All right, so I'm going to load the game now. Yeah, there we go. Okay, so you actually have 2 options of how to connect wallets to the site. You can use my Algo Connect, but for the sake of demo, I'm going to use the second option, which is to provide my mnemonic key phrase. So I picked that option because the game works faster that way. I wouldn't have to sign every transaction. So close this pop up. Yeah, get an error message. Okay. So connecting to my account. I'd like to create a new game. I just set a wager up to. Yeah, so we hold on while the contract gets created. Yeah, so at the other end, a friend of mine is going to be joining the game. So I'll let him see this contract address. All right, so he's copied the address, waiting for him to start the game. So I won't see anything on my end till he publishes his first move. So that's what I'm waiting for. All right, so let's play the storm. It's my turn to play. So okay, yeah, so let me just quickly explain this UI. Okay, so this here are the pieces that haven't been added to the board yet. So you can see blue. So for me, I have 5 pieces I haven't added to the board yet. For my opponent, he has 4 pieces he hasn't added to the board yet. He added 1 here. So over here, these are the total number of pieces I have. 5. My opponent has 5. So I'll just make my move. So as I said, for the first part of the game, we just take turns to place our pieces on the board. I'll demonstrate the restrictions that the game has for positions you can't place your piece. Yeah, so okay, my turn. I think I just play this. Yeah, so the game has a bit of latency because every single move has to be published. And after you publish your move and your opponent sees it, your opponent has to calculate the number of pieces you published and the number of pieces they published and publish that to the contract. That way, the contract runs a quick check to be sure that the information you both published tally.
All right, so I'm going to demonstrate one of the restrictions. So I'm going to try to place a piece here to complete a vertical match of 3 pieces. Yeah, so there's a message. You cannot place your piece here because it completes a vertical match. That means I have to place this piece elsewhere. Oh, and here there's a section that shows you the number of pieces you've captured, the number of your opponent pieces you've captured. But I would get to that part. Okay, make this move. Okay, I'm going to place the last piece on the board. Yeah. So right now, since all the pieces have been placed on the board, the next part of the game now involves moving these pieces around. So what I'm going to be trying to do, I'll try to place my piece in the place that would make me get a vertical or horizontal match of 3 pieces. All right, still waiting for my opponent's move. Okay, so I guess he moved this piece here. So I have an option of giving a match bullseye. Yeah, so as you can see, I just placed this piece in a position where I achieved a match of 3 pieces. I aligned 3 pieces. So that means my next move, I would be able to take away 1 piece of my opponent from the board. So this move would first get published, and then the opponent would see it and process it and agree with it. Then make it publish in the contract before I can go ahead to take a piece. So all these checks were put to prevent cheating. Yeah, so it's my turn. So I'll just pick a piece and take it away from the board. Take this one. So if you see here, the number of pieces I captured has increased by 1. The number of pieces left in my opponent's pane are 4 instead of 5. Actually, this game can stretch on for long. There are a lot of tactics involved, a lot of logic. But just to make this demo short, my opponent is going to be playing shit, basically. All right, so I have an opportunity here. I just move this. Yeah, I've achieved another alignment. So I'll publish that move, and then I'll wait for my turn to pick one of my opponent's pieces from the board. Okay, for the code side of things, the way I publish each move is I represented the positioning, the board and the pieces on it using strings, basically. So that is what I published in the contract. And the contract transfers that to my opponent. So I have algorithms that can decode that string and place the pieces on the board accordingly. So that was just how I did it. Yeah, my turn. So I think I'll take this one away. Yeah, so my turn to play. Okay. Okay, yeah, it's actually possible to achieve a vertical and horizontal match at the same time. So I'm going to demonstrate that with my next move. After my opponent plays, I'm going to this piece here to this place. Then I'll achieve a match here and a horizontal match here. So this is a match basically. So when you achieve a double match, you have the liberty to take away 2 pieces of your opponent. So double matches are like the thing to always aim for. All right, still waiting for my opponent's move. Okay, yeah, pieces captured 2 because I've captured 2 pieces. All right, let me achieve a double match real quick. Yeah, so I achieved a vertical match and a horizontal match at the same time. So that means I can actually take 2 pieces of my opponent. But that will be after my opponent agrees with the move, which is what I'm waiting for. But then my opponent has three pieces currently. So if I take away one, because I have to take them in turns, I'll take away the first one and then publish that, then take away the second one. But then, as I've taken away this first one, my opponent is down to two pieces. And according to the rules of the game, if the number of pieces you have are less than three, you've lost. So I've won this game basically, but I still have to wait for the contracts to calculate that. So any moment from now, boom, so you win. Yeah. So you have the option of playing again or reviewing your last game. So let me just quickly show that. You can just see a quick rundown of how the last game was. So these are the moves played. Blue, opponent is red. Yeah, so just in case you want to see what happened in the game. That's it. That's the end of my demo. I hope you enjoyed my game, and I hope you can make to try playing it. You just have to go to this URL. That's all. Easy peasy. So, bye, guys. Yeah, hello everyone. My name is Timothy, and I'm the team leader for the Gold Rush project. So I'll just get down to it and explain the rules of the game. This is new because I didn't get it from any of the other projects. So it's just a multiplayer game. It's a graphical game. It has a GUI. You control the player to navigate through a series of barriers and barricades and lava to pick gold. So there are three stages, and a player playing against another player, each take turns playing a stage. So in each stage, you have a timer, and you try to get you try to get all the gold pieces in that stage as quickly as possible. So basically, the player that takes the less time has the upper hand. So you play three stages. After stage one, you both play stage two, then you play stage three. So the player that has the least total time taken to get the gold pieces in each stage wins the game. Yeah. So I'll just take you through my index.rsh file. So yeah, these are the interact interfaces I use, the interact interface functions I use. Get time, opponent replay, inform timeout, show winner, inform the round. The logic of the game is very straightforward. It's very straightforward. It starts by Alice from line 87. Alice deploys the contract. She's the first to interact with the contract. So she sets the wager, sets the deadline, and publishes it to the contract. This line 96 is where Alice gets notified that it's actually something I used to keep track of the contract flow. So Bob then joins the contract, accepts wager, and pays. There's a timeout for this. This was the only place I implemented a timeout for reasons you would see later on as the game progresses. Anyway, the game is a loop, a loop that runs three times. So each loop represents each stage. So since Alice deployed the contract, Bob gets to play first. So Bob plays and he publishes the time it took him to finish his stage. He publishes it to the contract. Then Alice sees his time. She gets to see the time it took him, and she plays her turn. Bob plays his turn. Alice plays her turn. It ends with Bob seeing the time it took Alice, and the loop goes again. So what happens is at the end of the three loops, at the end of the three iterations, the contract based on the total time it took Alice and the total time it took Bob to play the three stages computes the winner of the game and pays the winner. So there's actually a possibility that the winner, there will be no winner, there could be a draw. So where I implemented the logic for determining who wins is here, a function, a winner, or winner rather. So there can be a draw, or Bob could win, Alice could win. So that's it for the board. I didn't do anything much here. This is the front end of our Gold Rush game. On the landing page, I have the option of connecting to my Google Connect wallet or importing my account here using my money key. It's safer to do this, but for the sake of the demo, I will do this. So I have the option of deploying the game or attaching to an already deployed game or contract. I will attach to an already deployed contract. I'm going to play against my friend now instead of playing as Alice and Bob here. I will be Bob and my friend will be Alice. So I'll just record my own screen. Yes, so my friend sets the wager to 0.2 algos. I will accept and pay. So this is the first round. As you can see here, this is the scoreboard showing on this scoreboard, we'll see the time it took us in each round. So when I click on this button, my timer starts counting and I have to finish the stage as quickly as possible. This same screen is what my opponent is seeing right now. So after we are each done, we both publish and his time would show on my screen. So I start the game. As we can see here, my timer has started counting. So I have to move my player. The controls are using the arrow keys on your keyboard, or WASD for the gamers. Okay. Yeah. And I'm done in 34 seconds. So what is happening under the hood now? Since I'm Bob and I get to play first, I'm publishing my time to the contract. After mine publishes, he then publishes his own. As we can see, his time has shown here. It took him 24 seconds, meaning it took him less time than it took me. I really need to step up. So we're at the second round now and start. This is
This is the most difficult stage in this game. I should have made it the third round. So I have to be careful. Okay, here's what happens when I fall into the lava. Just for demo's sake. Yes, this happens and I have to start afresh. I didn't need to show that demo because I'm definitely going to get my player roasted very soon. It's a very difficult stage, even for who built the game. Uh, I'll just be the patient one and go round. What am I playing? Yeah, so this is the most difficult part of. Okay. I have rehearsed this so many times. Yep. And I'm done. 73 seconds. Boom. Let's see how long it will take him. So, like I said earlier, I am playing as Bob. So I first published. So I did a little thing with promises on Alice's end because Alice has to wait for Bob to publish before she can publish Bob. She plays, then the front end stores her time until it's her turn to publish. Then it publishes it. That way, they both can place it simultaneously. Hopefully that makes sense. Yeah, it's taken a while because Alice is horrible. She's playing horribly. I'm sure of that. I said it took her 126 seconds to finish that round. So I'd say gaining on her right now. Then mere round 3. I might play it well, hopefully, because that is a feature in my game. You can crank the jump. Let me just get to it. Okay. Yeah, you can crank. Oops. Yee! Thank you. Yeah, that wasn't supposed to happen. How do I do? Okay. Yeah. Yeah. So. Yeah. So this should be pretty easy. It's 7 seconds. That's actually a record time for me. I always spend a lot of time on the stage. Yes, practice makes perfect. I hope he took a lot of time. So I'm about to find out. Yeah. So the contract has gotten to where it computes the yes, I win. As you can see, I won. It took me a total of 194 seconds, and it took him a total of 218 seconds. So I won. Yeah. That is the end of my demo. You have the option of playing again when you click on this oops, yeah, well, you choose to be an attacher or deployer.
Quick demo for the Umoja hackathon. So I have my application running on local ports. So I'm going to quickly test this application. First, I have to log in. As you can see, I have 3 wallets, and they are all connected in testnet with balance 10. That's for Bob, for Alice, and for Charlie. So I'm going to come here to load my application. So I'm going to load on different browser. All right, and here as well. All right, so I'm going to refresh this particular page. All right, refresh this. Now I'm going to connect with my Argo wallet as Charlie. I'm going to refresh this guy as well. Okay. Oh, pop up. All right, so I'm going to allow pop up here, and also I'm going to allow pop up here as well. So I'm going to refresh this page to accept pop up notification. All right, so I'm going to sign here as Alice. All right, sign my Argo as Bob. And then I'm going to connect. You can see, all right, select as Bob. All right, you can see that the balance on my Argo address is what's showing on each of these applications. Oh, here is just 9 Argo. Now, this is a hidden traitor game. So it's going to ask vote who the traitor is. So because we've not started the game, so we can't make a vote function. We can't go to vote. So we have to go to the game. So I'm going to click here as, all right, let me use here as Alice. I'm going to click here. I'm going to create a game. All right, Alice. I'm going to click create a game. So it's going to give me this passcode. I'm also going to click go to game here and also go to game here. So I'm going to copy this phrase, this seeds. I'm going to join the game as Bob. Bob here. I'm going to drop this code and join the game. I'm going to join here as well as Charlie. I'm going to drop the code here as well, and I'm going to join the game. All right, so I can now play the game while I've joined. So before the play game, I can read the rules to the game. Okay, all right. I think I lost the function for the route to the game. Oh, there's a particular route to the game. It's found on my GitHub, but I can just start the game. All right. So in this game, there are some rules that says you can choose who the spy is. Although once one player is randomly chosen as the spy. So we have one of these player, Alex, Bob, or Charlie, as the spy. And we have 3 actions. We have the spy action. We have the swap. Swap simply means you can change the role of a player. Since one player is considered a spy, we can change the role. So the other 2 players are considered an agent, which are the good guys. So we can actually change. This spy function can change. Why this swap function can change 2 roles: agent to agent, agent to spy, or spy to agent, depending on the case. But for now, we don't know what who is who here. So he's asking this first player to play the game. So I'm going to click spy action. I want to make Charlie the spy now. Oh, Charlie is the traitor. All right, so which is true. So this confirms, it tells me the role of Charlie. I know that Charlie is a traitor. Then I wait for Bob. Bob wants to play a confirm role. Bob says, okay, let me check what am I. So, oh, I'm an agent. So Bob is an agent. He agrees. And there's an event telling us what action is being taken here. Then Charlie wants to play is, oh, Charlie confirms as well. Oh, I wanted to click a swap. All right, so let's swap this guy. He knows who Charlie is as a spy. So you want to play a swap role. So he's going to click, he can as well click himself as a spy, to hold that variable or choose somebody else. So he's going to choose this guy. So you have swapped the role. So it's going to display that you have swapped the role of this. So Bob wants to play, he can't choose himself, so Bob wants to point at Charlie as a spy. So he clicks on Charlie, he discovers that Charlie is an agent. That's okay, wow. Then he confirms. Then Charlie as well wants to pick Alice as a spy. Oh, he discovered that Alice is also an agent. He confirms as well. Then since Alice still knows that it's Bob, but he's unsure. Why? Because these two people have played a spy action. So he's unsure who the spy really is. He tries to confirm, or he tries to swap, or he tries to confirm if he's the spy or not. So because the spy or the traitor, tends to lose in the game because they tends to lose basically in the game. So he's going to take an action now. So Bob is going to although Bob is still a spy. So let me just click spy. All right. So Bob is still the traitor. Yes, is the spy. So we confirm. So wait for this player to trigger. So this one can choose swap. All right, good. So you swap Alice and Charlie together. Not knowing that Bob is the traitor, so you just click a swap role. Sorry, swap these two guys together. Let me emulate my screen. All right, so you choose this guy and this guy. Okay, so it's changing the swap role from this guy, so it swaps. It swaps. Then it's left for Charlie to take an action. So Charlie wants to confirm. No, Charlie won't want to confirm. Charlie wants to pick a swap so that during vote time, you can vote for who the swap is between these two players. So you might choose any of these two to determine who to vote for. So, you vote for this guy as agent. So simply means Bob is a swap to him. So now, after this last action, you swipe. Okay, yes, confirm. So after this last action, we call the vote function. Now this is where our smart contract comes in, where we decide who the vote is, and using the get and function to remember who the voters really is. So we know who is voting and what we actually choose as voting. So I'm going to choose Bob as spy. Now, if you look, Bob cannot choose himself as spy, so he has no option than to choose either Charlie or Alice. That's why it's very you have to avoid being the traitor or the spy in these games because you lose it all because you can't choose the right person here if you are the traitor and you have to vote to complete the consensus. So you have to choose this one. Why him has to is going to choose the votes consensus. All right. So at the end of the game, he's going to see out this, then sign this contract, sign the transaction. Though I'm still having challenge with this, but sign the transaction to see who gets the actual vote. So we can discover that Charlie is the traitor, all right. So Bob is not the traitor, or some people lost. So Charlie is the traitor. Who got it right? Okay, is I think account B, which is not in that version.
Hey, so today I'll be taking you through the project demo for the microblogging app that I've been working on. When you first launch the application, it takes you to this beautiful landing page. And the landing page basically describes more about the project and the features that are associated with this particular microblog. As you can see, it allows you to communicate with your audience quickly via sending short text and images instead of writing long text. You're also able to analyze current trends as well as see what other chappers have been chapping. In this case, chappers refers to the users of the microblog application. So ChapChap allows you to send and receive tokens you can send these tokens to other users or your friends within the application. And also as a creator, you get to receive gifts from fellow chappers. So once you click send gift, it brings you to this page where it shows your wallet balance and the amount of tokens, or rather algos that you have sent to fellow chappers. So for this to be displayed, you need to connect your account. If you don't have an account, you could choose to create one. And if you already have a pre-existing account, you could choose to import your account. So once you click on the import account button, it shows this pop-up where you're meant to input your wallet mnemonic. So in this case, I could try to input mine. But before I do that, you can see that on my test net, actually let me choose my net. You can see I already have my account over here. And at the moment it doesn't have any cash. So when I do import, when I click over here, it's meant to import this account into the application. But then I think there's a network error at the moment. So once that is out of the way, as a receiver, you could choose to also receive your gift, and the same thing will happen. You'll be able to see the balance in your account. Yeah. So this Chaps page allows you to chat, rather send short messages or even attach images or videos. So in this case, we can see that we have earlier chaps from fellow chappers. So if I want to update them on what I'm doing, I could just text and say, maybe I am listening to music, and chap. So the beauty of this is that I don't really have to log in for my chaps to be posted. Yeah, so that's what it means by chapping anonymously. Like no one else needs to know about your identity. Yeah, so basically that's it for this project demo. The rest are features like notifications, settings, and frequently asked questions about the application. So thank you for your time. That's it for my project demo today.
Hello, Rich community and the team. My name is Musa Wengosinjela, and I represent the Griffins team. So we developed a municipality budget checker where it allows the community to see what the local municipalities spend the money to, and where do they get the money from. So I'm going to show you how this app works. So the first thing that we're going to use the local municipality. So let's go to local municipality. So if you don't have an account, just press register. So register, then we are going to use maybe, let's say, gmail.com. Then here, what you are going to put is the what type of municipality. So let's say that I'm gonna take one type. So maybe city of Ekokoleni. Then, or let's just take city of Tshwane. Sorry, city of Tshwane. Then we're gonna put city of Tshwane there. Then it's gonna be, let's maybe Chris. Let's just put Chris. Then the password 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we're gonna register. So copy account and Minomix. So this account, this is the account that you are going to use to interact with or to send a request to the treasury or national government. So let's just copy it. So copy. Okay. So now you can just save it to where it's safe. So I'm just going to paste it here. I have already created the account for Treasury, since it's going to be one Treasury. So I have already created that account. So we are going to take that municipality account, wallet address, then we're going to log in using that one. So CFC at Gmail. Sorry, gmail.com. Then I'm going to log in and paste it, then okay. So if you don't have algos in your account, then you can log in, then you have to go to the bank to, I would say, algo dispenser. So just put, then I'm going to paste it here, then I'm going to dispense. Okay, then you can log in. Yes, so there it is. So the first thing that we're going to do is to deploy the request. So when you deploy a request, you're going to see the national government there. Then you can just put the description or where are you going to use this money or what are you going to use this money for. So let's say I'm going to build a road in Tshwane. Then for maybe how many algos, so you can just put 2, just a little one. So deploy the request. So now I'm going to deploy the request. So when you deploy the request, you have to cite it, which means you have to put that Minomix. So let's just grab that Minomix there. Then copy, then paste it here, and then okay. Let's wait just a few seconds. Then paste it again to confirm, paste it again. So there it is there. So build road in Tshwane, so price 2 to national government. So I'm waiting for that request to be accepted or maybe rejected. So from this side, we are going to log in as a treasury. So let's go to accept that request. So let's just wait for a second, and I'll enter the treasury email address and log in. Then I'll put the address of the treasury, copy. Then okay. So So as you can see that the treasurer will have multiple requests. So he can accept, reject. So here you can see that there is this bill road in Tshwane, price 2 from the city of Tshwane. So we are going to accept that request. So accept, okay. So accept it. Now we have to, from this, you have to sign that request again. So let's go. So let's take that vanilla mix. Sign that the accepted request. So okay. Let's wait just a few seconds. And then let's paste it. Then I'm going to say okay. Then paste it again. And everything is okay. So now let's go to the city of Tshwane municipal account. So it was csc@gmail.com. Then we're gonna log in. Then let's grab that wallet address. Copy. As you can see that the request has been accepted. So as you can see that, so the treasurer can accept multiple, can accept 1 or 2 requests. And you can see that from the municipality, you can deploy that request or attach to a request. So when he attach, that means that it's when he accept or reject a service provider's request. So what we are going to do now is to attach. So we're going to create a service provider, then deploy a request, and then we come to this side and then attach that to that request. Okay, now what we are going to show now is the interaction between the service provider and the local municipality. So the first thing that we have to do again is to log in. So if you don't have an account, just register. And we're gonna just say maybe ZSC. Gmail.com. So remember that here, what you are putting in the user type function is the name of the account or the name of the municipality. So let's just check, take one company, maybe Fusion Business Solution. And I'm gonna type it here. And let's say first name is gonna be Zinc. I'm just throwing names. So let's just put 1, 2, 3, 4, 5, 6, 7, 8, 9. Then after you've done that, then you can register. Again, we have to copy that account and mnemonic maybe somewhere safe. So let's do that. Let's copy. And okay. Now let's paste it somewhere safe. Then let's just grab the wallet address. Then when we log in, we use ZSZ gmail.com. So let's log in. Again, if you don't have the algos in your account, then you can't log in. Then you have to go to the bank to ask that to give you just a little bit of algos. Let's dispense. Okay, so now let's paste it. Then paste. Then okay. Then there it is, Fusion Business Solution. So now, where you see in the service provider, since we are sending a request to the local municipality, then you can have a list of local municipality, and then so you can just select the one that you want. Remember that we were using the city of Tshwane, so let's just select that one. And then let's say maybe transport service maybe just create algo, and we can send that request. Then we have to again put those mnemonics there. Just wait for a few seconds to confirm. Then we have to, so transport service goods and price, city of Tshwane, and we have to wait. So now let's go to that account of the city of Tshwane. So let's say, let's see. Then let's log in. Let's go and grab that wallet address. Okay. There we go. Now, since we had this one to the national government, but now we want to attach to a request. So let's press attach to a request. Then you can see that transport service goods, price 3, and then Fusion Business Solution. So we can maybe accept or reject. For now, let's just reject this one. So let's just reject this one. Then when we go to the service provider account, so let's see, z at gmail.com. Then we're going to say log in and take this provider. As you can see that they have rejected the request. So we have done the interaction between the municipality and the service provider. So now what I am going to demonstrate is the community view, where we can see all transactions that were made by these different different participants or users so that the community can see all that. So now let's view that. So let's go to community. And just wait. Now I'm going to showcase now or show you the community tab or the button community, where we are going to see all the transactions that were made. So let's go. So we are going to just wait to see all transactions. So these are all the transactions that we made. So from national government to the city of Tshwane, then from Nelson Mandela Bay, these are the previous one. Then let's look for okay. So since we have rejected the one that come from Fusion Business Solution, so it won't appear here. So let's just filter if we, let's say that we want to view by treasury, and then the national government or municipality, and then you choose the municipality, and then let's say service provider, service providers, all of them. So now let's just take one municipality, and then let's just say maybe city of Johannesburg, and then save changes. Then we can see here. And maybe let's take service provider, then maybe 80, save. So there it is. So this is the tab for, so they can see all the transaction, filter the transaction based on the user or whatever user that they're looking for. So yes. So that's all that the municipality budget checker do, is to see every transaction that has gone through from the local municipality and the interaction between the local municipality and the treasury and service provider and local municipality, and so it can show every transaction. So thank you for your time, and I hope you enjoy.
Hi, I'm Zayden, and I'd like to talk you through my Reach project, which is an NFT library system where authors can come in and publish their books as an NFT, and we can read the NFTs in the library. So how it works is when you're reading the book, you pay per page that you read. Now this is the file where you pay whilst you're reading, and this is file for publishing. As you can see here, it connects to my smart contract, and this is the file with my smart contract. And so now, this is what the system looks like so far. So here, I click this to let me publish my book. If I click this to let me go into the library and read a book. So this is the idea so far. Thanks for your time.
Hi guys, my name is Melvin Ofula. My teammate was Titus. My mentor was Ayomikun. I'm going to take you through an NFT auction with Rich and Svelte. For the front end, we used Svelte. For the back end, we used AWS Amplify to save the images for the NFT. We also used AWS Authentication for authenticating users to be able to log into the website. The application was meant to run on Algorand, but we're running into a few issues with actually accessing the contract on Algorand. So for this demonstration, I'm going to use Ethereum. I am connected to the Ethereum private network on Ganache CLI. I have opened 3 Chrome tabs with 3 different users to demonstrate 3 different users. I have 3 different MetaMask accounts connected to the private network. I'm going to go ahead and start the app. We are running a local server on a local SSH. This is the login page. If you're not a new user, you'll have to sign up before you access the app. But since I'm already a user, I'll just log in. This is the landing page. Here is a username, and here are the NFTs. If you upload an NFT and you're the owner, you'll have an auction button. But if you're not the owner, you'll have the bid button. If you press the auction button, you'll have an option to start the auction. If you want to bid for an NFT, you have the option to actually bid by entering a contract and sending and waiting to attach. This app is supposed to run on Algorand, but we're having a few issues with the bid API. So I'll just demonstrate on MetaMask first. So let's connect to our wallet. Yes, it works. The wallet appears here and the balance. Now, since you're already connected to the wallet and you're already a user, you have the option to actually create an NFT. So we give it NFT symbol, NFT description, and place a price. Choose a file. Okay, so let's upload this image. So what's happening right now is just going to create the token and then send the image to AWS. That's Amazon Studio. So let's reload and see where it is. There it is. So we can auction, but we need bidders. So I have these other 2 accounts. This is BMCs and Jama. We're going to connect to the MetaMasks if they will allow us. No. Yes, that will work. So now they are connected and have a balance. Let's start the auction. So they're going to wait for a contact address. Ideally, this is going to be happen with a web server, with a web socket. But for now, we just copy and paste. So start auction. Okay, here's the contract. So let's copy the contract to the bidders and see if it will work. Okay, bid amount for yeah, there it is. So the initial price and the bid. Okay, so we're going to do 5. Yeah. So we continue. Submit bid. Confirm. Yeah, so 5-4. Let's see if the auctioneer saw that. Yeah, so that's happening. Transaction. So let's up the bid. 7. So 7. 7. Yeah, so basically that's it. I don't think I don't think Ganache is is mining blocks automatically. So I don't think it will end anytime soon because I put a very long blockchain block time auction time. So yeah, that's the demonstration. Of course, there's a lot of work to do, and I'm looking forward to meet with Estefania and see what the issues are with Algorand. because it's connecting, but I can't place a bid. It brings out an error. For Ganache, I don't think Ganache actually means blocks automatically. So, and I put I think 120 blocks for before the auction ends. So I don't think it's going to end anytime soon. Yeah, there is a lot of work still to be done, but this is the basic. Thank you very much for your time and for this opportunity.
So hey guys, this is my video demo for my project for the Bounty Hackathon. So let's go right into it. So I'm opening the application. It's taking some time. All right. So this is the application. Yeah. So let's play. So let's start as James and John. So the accounts Monique. So I created 2 test accounts. I'm not using this, although I'm deploying this contract on the main net. Yeah, just for this video's purpose. So enter. So let's just use 0.4 algo. Enter. Hope you guys can hear me. Yeah. So let uh let James win this first round, and then rock and scissors. So rock. John is going to win this round. So paper, and they're going to draw. So it's going to even out. So the match is going to end. The game is going to end as a draw. So here is like the log of everything that happens in the game. So we'll enter. So it's going to take some time to run. So let's just check the accounts, the test accounts I used for the projects. So let's just check. Let's check if it's deployed. For you too. So let's see. Yes, transactions. So yeah, less than a minute ago. Deployed. That's for Alex account. Checking here too, less than a minute ago. So yeah, it deployed. So at the end of the game, the contract distributes the funds, So if you want to play again, you can just tap here, play again, impute what you want to impute, and then when you're done, you exit the game. So that's all for the video. Thank you for your time.
Hello, this is Isa, and today I'm going to be presenting my Reach application that was built for the Umoja hackathon. So basically, the concept of the application was an insurance tab. So it was meant to be a social insurance platform where a specific party or participant initiates the insurance product as an insurance company, and thereafter you have subscribers that will subscribe to that particular policy and start making payments and so forth. Okay, so basically in the contract we have both the insurance company, which is the individual that initiates or deploys the contract, as well as the subscriber. The insurance or the insurer is basically able to set an installment amount that needs to be paid.
and the subscriber that subscribes to that particular contract will have to make the necessary payments at a specific interval. And once payments have been established, the party being insured is able to then request for payment, and the insurance company or the initiator is able to then approve the payout. Okay, so basically, just cancel there. Okay, so if we run reach compile, okay, just wait for the compilation. Okay, the contract has successfully been compiled. Then we can just run it quickly on DevNet. Now, in terms of the front end is pretty basic. The users are able to connect their wallets. As you can see, my wallet is already connected with my balance there. And the initiator will then go ahead and deploy the contract, and will be provided with the contract details, and the subscriber would be able to attach themselves to that particular contract with the contract information from the deployed, and as such, they are then able to make the necessary payments towards the contract. There is one or two bugs that I'm currently facing in terms of the actual deploy. I don't exactly have any errors here. However, it seems to be hanging, but that is basically the gist of the application and the reach contract that has been put together. I thank you very much.
Hi, I'm Soraya, and my project of choice is tic-tac-toe with a wager. Okay, so the first thing we're going to do is we're going to build and run the project. Okay, it's compiling. Okay, we're in now. The game has two modes of choice, simulation and a live game. So we'll choose simulation. So we'll click on one. And then it's asking us, do you accept the wager? We'll say yes. And there we go. And the game is done. So I'll just talk you through the first steps. As we can see here, it started off by deploying, and Bob started first with an O, and then it was Alice's turn, Bob, and then Alice. And as we can see, Bob was the winner of this game. All right, thank you very much, and I look forward to seeing you soon. Bye.
Federal Republic of Nigeria, and I worked on the unit number game. So I'm going to be walking you through what I did on the game and how I was able to get this game working, and the idea that came behind the after result of this game. So I got a topic to work on the unique number game. So what I understand by the unique number game is where some players get to play a game that entails different numbers. So when they get the actual non-predefined number right, they get to win the game. So I put this idea into play, and I had to use my imagery to devote time to actually create an idea behind the game. So I worked on 4 characters of the game. So we have 4 characters. We have the ghost, we have the witch, we have the pawn, and we have the mouse. So each of them are assigned a unique number. So the ghost is 0, the witch is 1, the mouse is 2, and then the pawn is 3. So that is 4 numbers. So for every iteration of the game gets to randomly shuffle these numbers while players play. So I don't just want to make the game in a way where you just pick a number and they tell you pick 1, you won, or you pick 2, you won. So I had to assign this number as a character to make it more interactive, like to build how would I put it now, an interface where users can actually feel what they're playing at the time. So this is my GitHub repo. So I'm going to walk you through my codes and how I was able to come up with the idea behind this. So I'll take you to my source folder where I have my index.rsh. Okay. Okay. All right. So this is my index.rsh where I wrote all my code. So I started with defining a Boolean value is cards. Then each card, the 4 cards, the ghost, the witch, and the pawn, and then the outcome, which is result. And its result takes in 3 values where we have Klaus win, draw, or Elena wins. So when I have a function that is called winner that tends to perform a particular task based on some conditional statements on who wins or who loses the game. So we have if Klaus equals to ghost, that means if Klaus get ghost and Elena get ghost, that's from line 8. Elena wins or Klaus wins, as the case may be in the game. So then I had to use my assert winner to check also on the outcome of the game. So if the winner is if Klaus gets ghost, meaning Klaus and Elena gets witch. I know it's a bit lengthy, but I had to do this way just to ensure that I get everything right in every iteration of the game. So moving forward to the card, then I had the players where they get cards that takes in a function, the view results, the timeout, and the inform if there is a draw on each of the users. Then Alice also has a wager, and Klaus also has a Klaus brings up the wager. Elena also accepts the wager as it was defined in the game. So it is pretty much it for my GitHub. So I'm going to walk you through the game now. So I'm going to open up, it's already open here. So this is the game. So I'm going to take you back to the home page. This is actually deployed on Microsoft Azure. Okay, so then you go to play the Demon game. Then you have to pick, you have to create a new game, or if you have a contract address, you can actually join existing game. So since I want to play this for the demo sake, I'm going to create the game, a new game. Then I'm going to add a wager. I can just say maybe 2. Then I submit. Then I submit this wager while it is loading. I'm also going to copy this address again just to serve as 2 users playing. Okay, so I'm going to do this. Then I'm going to open a new browser. And I'm going to paste this here. Okay, so I'm going to move this GitHub here. So, okay, so this is another user playing. So I'm creating an existing game. So I already signed in with, sorry, I had to skip that part. So I actually signed in with a numeric key. So I had to use a numeric key to sign in so we don't keep getting the pop-up for every step we play on the game. So creating a new game, I just have to open up this, take the contract address, get to this guy here, and he's trying to play the game. So I had to sign in on the other guy by default so we don't get to keep getting this pop-up. So I'm going to do the same thing for these two. So I'm going to cancel this. So it tells me, do you have a numeric key? So I'm going to say yes. Then I'll go to where I already pasted that key. So I'm going to go where I already pasted that key. So I'm going to copy all this. Then I'm going to copy this. I'm going to come back here. And I'm going to paste it so we avoid the whole pop-ups and all. So that means this guy is already signed in. So join existing game. I'm going to copy the contract address of this user. Then I'm going to copy this and I'm going to paste it here. So sign in, you can see the second user has properly signed in and is saying accept the wager. So I'm going to click on yes, accept the wager. So I'll move back to this guy to wait for it to reflect. Okay. All right. So finally, we're in the game now. So the next thing we're going to do is play the game. So you can see it said it's your turn to pick a card. So I'm going to pick a card, any card. So he said you played the card which. And remember, according to the rules of the game, you only win the game when you have ghost. And only I know that ghost is in the index 0. But for every iteration of the game shuffles the number, it randomly shuffles the number. So you can't really guess what number you are going to play. Or so the cards are just there, they don't represent per se a particular number. It doesn't mean when you click ghost, you get ghost. No. So this image here is ghost. This image here is the witch. This image here is the mouse, and this is the pawn. So it doesn't mean when you click pawn, it means you win. No, you're going to get pawn at the back. No, you're not going to get pawn because these cards are just a figurehead. But behind the scene, these numbers are being shuffled randomly. So he picked what? Witch. So the next user I'm going to pick, okay, to clear the points, I'm going to pick this card now that signifies witch, but you can see it gave us witch. Well, that was a lock, but okay, let's move on. So you picked witch and you also picked witch. So according to the game, this is a draw because we need to have a ghost to win. And if we don't have a ghost, we keep playing till we get a ghost. So I'll wait here and see. So we should expect a pop-up telling us it's a draw. So it's informing this user it's a draw, and then it's informing this user it is a draw. So we need to play again. So the first user has to play again. It's a turn to pick a card, and then he picks a card. It's witch again. Wow, that is a lock. So now we need to play again. Let's see. Hold on, it's not your turn to play. Oops. Okay, so we have to wait for our turn to play. So now it's our turn to play. So wow, I picked the ghost. Okay, so you picked witch, you picked ghost. So definitely this user won the game. So we're gonna wait for it to populate. Then we should get the information of who wins or who loses the game. Okay, so you see, you found ghost, you won the game. Then you lose. So this is typically my unique number game. So to rephrase everything I've said thus far, so it's a unique number game that's been assigned that has been assigned 4 numbers that are randomly shuffled by the game to give us a winner. So in that 4 numbers, you only have one number that makes you the winner, and that is ghost. And ghost is at the index number 0, but it keeps shuffling at every iteration of the game. So ghost may be number 1 in the first game, and next game it can be number 2. I'm talking about based on the card arrangement. So typically that is about my unique number game. I'm so excited. I was able to build this, and I'm so excited of this game. And I hope you enjoy playing it too. Thank you very much.
Yeah, so I'm working on a project called Basic Diary, which simply is a kind of project that users can come and vote for their preferred idea or option, which is actually given by the system. So I'm in my .rsh file where I have my participants interact interface and also my participants interface. Under my participants interface, I have user 1, user 2, and user 3. These are the users that can vote. And I have proposer 1, proposer 2. These are users that these are the users that are going to propose the idea in which the user 1, user 2, and user 3 are going to vote on.
So this section of the code is where they declassify their interact objects. That is the user one, user two, and the user three. And this side, this part of the code is where I have the vote logic. This is where the voting logic takes place. Now, so heading to my .mjs file, I have the account set up, the account set up, and I have my proposal one, creating the backend and other users attached to it. Now, in the code here, the proposal one actually proposed the idea, the first idea, which is increased volatility of assets, and proposal two proposes the second idea, which is make system decentralized. Then here I have my user one, user two, and user three, where user one sets wages of 200 and views the ideas proposed by proposal one and proposal two. And also, the user one can vote for their preferred idea, which is taking place here, the vote idea here. The same thing too applies to user two and user three, where they accept the fund that was proposed by user one. And this part of the code is where the balance of each users is displayed before and after the voting took place. So I'm going to run this program to see the outcome. So as you can see, the first and second idea is displayed. Then user one views the idea, views the first and second idea. User two accepts the token and also views idea. The same thing to user three pays 200 to the network and also views the idea. Now, after the voting takes place, it displays here that idea two has their yes vote and their account status is shown here. Yeah, thank you.
Hi everyone, my name is Victoria Elohoy Jumegu from Nigeria. I'm here to present a project called Freedom. It is a microblogging app that helps for interaction and for quick messaging, whereby you make a post and your viewers or audience can comment and reply to your post. This project was built on the Algorand blockchain using the Rich platform to facilitate it.
So presently, the project is just in the development stage yet because I'm still having issues with the web interface.
All right, so far it was quite the process of the project was quite tasking though, yeah. And the limitations I had was the constant update on which kept affecting my compilation and deployment, and also it was really not easy for me differentiating between which file which file represented the front end and which one represented the back end. And also I did not really know that MJS was a JavaScript on which, so I kept on using JS until I got clarification from my mentor to use .mgs, which helped my compilation and deployment. So thank you.
Hey everyone, my name is Merdy Kim and I'm the builder of the NFT with Royalty project. So with no further ado, let's jump in the project and see how it works. So here I'm first going to walk you through my reach program. So first of all, the NFT royalty work as follows. We have a creator who creates an NFT that will be uploaded to IPFS, and the metadata will be stored in this object right here. So in the object, the NFT object, you have the metadata, the price, the creator's address, the owner's address, and the royalty percentage. So on the creator interact, we get the metadata. This comes from IPFS. We have the price, the royalty, and you also have a function that will be signalizing to the front end that an NFT has been minted. So you have the buyer's side where he's going to get the NFT from the front end, also the ID, so that later on that gets changed on the front end. And again, a function that takes in an NFT, and the bytes 20 will be the ID, and that will be signalizing to the front end. So we initialize the application. Here we create the NFT. We publish that to the network. So this is the consensus step. We mint the NFT and we commit that to the chain or to the network. So the buyer, when a certain buyer comes and buy the NFT, we are going to have here the NFT to buy that has been indexed and the index or the ID of that NFT. So right here we publish that NFT to buy, we publish the ID, then we pay the money of the NFT. So this is where the royalty comes in. So we calculate price one is going to be NFT price divided by NFT royalty. So if the royalty is 20%, we are going to get 20% of the money. It comes in P1 and the rest of the money in P2. So as it shows here, we are going to transfer the P1 to the creator of the NFT, so the person who minted the NFT and who deserves the royalty, and the rest of the money is going to be transferred to the current owner. So after transferring the money, we change the owner to the person who has just bought the NFT. So you can see your owner is now going to be NFT buyer. And so we send that to the front end so that we can index that and retrieve it in a marketplace. So with no further ado, let's try to see how our marketplace works. So here we are going to have, this is the project. So I minted one NFT and we also have one other side. So this is going to be the creator. We are going to mint one NFT here and another NFT here. These are two different addresses. So let's kick it off and mint an NFT. So here I'm just going to say my second NFT will be Disco, maybe. So this is a party that we had yesterday. So that's the metadata. Yesterday. Okay. So next step, I'm going to say that the price, I'm going to say one algo, the percentage that will be 20%, and I'll choose a file that I'll mint. So in this case, music party. So this is the NFT. So I mint that NFT. So as you can see, this project is deployed on mainnet. So we are going to pay real money, and it's going to take to go through. So wait for it. As you can see, this prompt us here to to open our wallet. So I've opened my wallet. Now I'm going to sign the transaction. So just a second. When that is going through, I'm just going to put in my password again. And after here, the NFT should be minted. So as you can see right here, our NFT has been minted. And as you can see on the right, whenever you
whenever you hover over an NFT, you see its metadata right here. So the next step here, we are now going to try to buy an NFT. As you can see, these two NFTs has been minted by the same address. And this is the same address. So it generates a profile. As you can see right here, the profile is still the same. So if we now try to upload or to buy an NFT, we are going to switch to the second side, okay? And I'll refresh. And right here, before we switch there, I'm first going to show you the balance that is in my first account and the balance that is in my second account, so that you see very well how the royalty is going to be implemented. You see here 3 algos in my second wallet. You see 1.99 algos. So I'm going to connect my second one to buy this NFT that costs 1 algo. Okay, so don't forget, I have 1 algo, 1.99. On the other side, I have 3.95. So now I'm going to try to buy. So if I buy this, I'm going to be redirected to my wallet. So I'll first need to open my wallet, then to send a transaction. This is the second wallet. So like after this, it's now going to prompt me. As you can see, it's still loading here. That means it's processing. So now I'm going to send a transaction, and you'll see the address changing. Okay. So here, I'm first going to approve this. It's some weird behavior that I realized come in. So I'm going to say here, put my password. I sign the transaction. As you can see, these are still the same logos and these are still the same addresses. But wait, when this finishes to load, you'll see they will change. The addresses will change and these logos will change. So let's give it a second and see how it goes. So right here, the address is now A3D. On the other side is still AA5 because no one has bought this. So as you can see here, the owner of this NFT has changed. But now let's check the wallet to see if the money has gone. And yeah, 1 algo has gone. So where has it gone? We go to this wallet. Now we have 5 algos on the other side because it's the first sale. So the owner is also the creator. So he'll get full amount sent to his wallet. And that's how I can prove that the NFT has been sold with royalty. So here I'm going to need to refresh to see the changes. And boom, you see now we have a new address. So that's it for this showcase. That's the project that I built for the purpose of decentralized Umoja 2.
Hello everyone. Today I'm going to be showing you how to use the Reach plugin on Brackets text editor. So we start by opening brackets and we create a new Reach file. So we name it index.rsh. Then let's create a basic Reach application. We use Reach version. Since we've opened an RSH file, the Reach plugin is loaded automatically and gives us hints and keywords to use. So you can see we've used export and const. We can use this hint to split things up a bit. So let's create a participant. Yeah, just use this hint. then we use request hint. We have the int here. We have info. Then we have byte. And we initialize, just call an init function. The plugin completes that for us as well. And then we could just go on with this and publish. Here we can select declassify. So yeah, the plugin completes that as well. Then we have interact. Then here we move to our publish function. And then after that, we call commit. So now we have our simple read application, and the next thing we want to do now is to compile. So we just click Start Reach Compiler. So this could take a while. Okay, so from the output, we can see that the compile was successful. Thanks for watching the video, guys, and let me know what you think.
The sec.
All right, everyone. Thank you all so much for watching. Stay tuned for the landing page and email that will come with everything you need to know about voting. We really appreciate you being here and watching all of this. Again, if you have any questions, feel free to send us direct messages via Discord, Twitter, etc. We look forward to hearing you, and thank you so much for staying tuned with all of this. This was incredible. I'm so excited to see even the projects that have yet to be submitted. There's a few left. So thank you all so much. Have a great rest of your day, evening, or night, wherever you are in the world. And